Nice. Welcome to All Understanding Learning web series. Today topic is 8051 microcontroller architecture or black diagram. Let us see the one by one components of the 8051 microcontroller architecture. The first component is CPU, Central Processing Unit. See there, for any microcontroller, the entire functions are working from the main unit that is called as a CPU. The Intel is introduced this microcontroller in 1981. Now what CPU will do? In any computer, the CPU will perform the arithmetic and logic operations. So in 8051 microcontroller, it will perform the number of arithmetic and logic operations by three registers. One register is called as A, the other one is called as B, the third one is called as a PSW. Now all these three registers, what is their function? Let us see. A is the, see there, this is the A, register A. A is the accumulator that will save or store the results of ALU, nothing but arithmetic logic operations in a CPU. So whatever the arithmetic and logic operations are taken, the results are stored in accumulator A. Now the register B is used for the multiplication and division arithmetic operations. Now let us see the third register. What is the third register? It will do, it will stores the entire results of a any operation. Like 8086, there is a flag registers. So all results and their status is stored in the PSW. What is the status? We know that in the 8086 computer, that is you observe that it can store the whether the results consist the zero flag or not, whether the results has a odd parity or even parity, like a parity flag, whether the results consists a carry or not, like that. The results are stored in the PSW, program status word. So this is the entire three registers in the CPU of 8051 microcontroller. Now let us see the one more important term that we are going to be used for any computer, the oscillator. See there, what a oscillator will do. The oscillator for any computer, maybe small computer, maybe big computer like 806, it will provide the clock pulses that will synchronize the all internal operations of a microcontroller. So this will be provided by two pins. One is called as XTL1, the other one is called as XTL2. So these two are connected by a one crystal oscillator with 233 picofarad ceramic capacitors that will provide the clock pulses for the microcontroller unit called as a MCU. So this is the one more important part of a 8051 microcontroller to synchronize the all operations in the microcontroller. Now let us see the one more important function, that is the user can interrupt the program at any time. So the interrupt control is required in a any computer like microcontroller also required the interrupt controller. This interrupt controller is a simple function that can be controlled by the nested vector interrupt controller. There is a one simple register called as a interrupt vector table. According to the priority given in the IVT, the interrupts are controlled in the microcontroller. Now the next one is ROM. We know that the ROM is a simple memory that will stores the user program instructions like a main computer 8086. Now here also same thing, the ROM will stores the whatever the users are giving the command to the computer, that is stored in the ROM. So 8051 microcontroller has a, what is the size here? See there, 4 KB size. It will store the instructions in the 16-bit form. For a 16-bit form, see there, what is the inter starting address of a instruction? 000H to FFFH. So the 8051 has a 4 KB size, and next one is one more after 8051, one more powerful computer, microcontroller, a small computer is designed for 8052 series. It has a double size. See there, it is a 4 KB, now it is the 8 KB size. Now some more computers are came, some more microcontrollers are came to the market until up to 32 KB in one different versions of a microcontrollers. Now let us see what it will do. So it has a two 16-bit counters. So one counter is called as PC, that is program counter. It will store the address of a next instruction to be fetched. There is one more register, that is DPTR, nothing but it is stores the information which is going to be fetched currently, nothing but current instruction going to be fetched. That information is stored by the DPTR, data pointer register. So this is about the RAM used in the microcontroller. Next memory device is RAM, RAM. Let us see what is the RAM. See there, the RAM is a 8-bit address. It will show the address of any instruction. That we know that this RAM is having the size of 128 byte. The latest RAM, it is extended to until up to 256 bytes. See there, 256 bytes, that is 8052 microcontroller. Now because of it is 8-bit register, the starting address of instruction is starting from 00H to the final address is 7F. In 8052 microcontroller, the next address of is 7F. What is that? 7F 80HH. To the last address is FFH in the 8052. So this is the RAM used in the microcontroller. We know that RAM, whatever the written program, that will be deleted when the power is off. When the microcontroller the energy is off, then the memory is delete the all written program data, so that it is called as a volatile memory. So the RAM is named as a volatile memory, like what we discussed in the 8086 main computer. So this is about the component called as a RAM. Now next one is, let us see different components. IO components, IO ports. We know that there are four ports are used in the 8051 controller. The purpose of this all 4 ports, let us see. See there is a port 1 P0 named as P0. It is the AD bus. It will carry the multiplexed address and data bus AD0 to AD7. Whereas P2 is carried. What is the address bus? See there, A8 to the A16, because 8051 is 16 address bit microcontroller, whereas the data is 8-bit only. So now the P1, see there, this is the P1, port P1 is used for the IO devices. Whatever may be the input output devices, we can interface through the P1. Now the P4, the last port, that is used for the time controller circuits. The time controller circuit are controlled by 2 resistors. One is called as T0, T1 in the microcontroller, in the 8051 microcontroller. Now see there, serial port is dedicated for only transmit data by the command TXD, receive the data from the command RXD. So this is dedicated for the transmit and receive the data from the other devices. This is about the IO ports and serial port. Now just we discuss now. There is a 2 resistors, the timer resistor, that is T0 and T1. This is controlled by the TCC. Now there is a internal bus. Let us see the entire thing. See there is a internal bus control that is used for managing the control operation while the CPU is working with a RAM. Now these operations, you observe that the time control circuit generate the delay for each and every operation. For one operation to other operations, we have seen the applications of 8051 for different applications. There, depending upon the applications, for every operation the delay is required. Who will provide the delay? The time control circuit provide the delay. These time control circuit providing the delay by using the two timers. One is called as T0, timer 0, the other one is called as timer 1. For any required action, this delay is provided or generated by the TCC. Now let us see the entire architecture of a 8051 microcontroller. This is the entire architecture of a microcontroller, just what we discuss, including the all components or all black diagram components of a microcontroller. If you want, you can take a screenshot. Now for the purpose of understanding what I discussed with you, now the students can have a screenshot all these 8 points what we discuss. This is the point number 4 and 5. Next, this is the point of 6 and 7. This is the point 8. So this is the available for the screenshot. If you want, you can take it. Thank you one and all.